So as I was saying, I hope that you really went and see where the derivations came from and what is the mathematical formulation. But going straight to the points that you are the most interested about, which is the exam. Uh, yeah, you're gonna have to know how to do moment of inertia and centroid by areas and by integrals, both ways. So I decided to do this problem with you, to share this problem with you today in class. And you should, there are different ways that you can solve the same problem, different ways. I explained once again in several videos, you can, and I'm gonna try to just at least mention how to do that because everybody learns different and everybody has a, a preference in how to solve these problems. So uh, I start all the time by the formulas. With the formulas, x bar is the integral of x dA divided by the integral of dA. These formulas come from the derivation that I did, and y bar is the integral of y dA divided by the integral of dA. And there are two methods. The first method, of course, obviously this is a problem that you are going to do by integrals because it involves it's involving functions and equations. Uh, the first thing that you should do when you, no, the first thing that I do when I do these type of problems is I look at the variable, I look at the variable, this variable first, and let me move this away because it's bothering me. Okay, so I look at this letter here and I say, okay, this letter here is telling me in what direction I am measuring what I'm measuring. The idea is that you're going to measure a distance y, for example, and then you're gonna select the differential of area. There are different ways, as I'm telling you. This is the easiest recipe to follow if you want to follow a recipe. Then I'm going to try to select the differential of area that is perpendicular to that one. This is my differential of area. If this is the differential of area and this is y, this distance is dy. And the only thing that I need to know and I need to finalize to calculate this is this distance from here to here. And that distance from here to here, if I want to know what is the differential of area there, that differential of area is going to be given by this distance, which is defined by this equation. So it's going to be x in that equation multiplied by the thickness, which is dy. And from this equation, I can solve for x, and then x is going to be equal to the square root of this, 4 times this, so it's going to be 2 times y to the 1/2. That's going to be that x over there. And my differential of area then is going to be that value, 2y to the 1/2 multiplied by that dy. Once you have that, the only thing that you have to do is plug that in here, and the problem is solved. That's it. If you know a little bit of integrals. This is one way of doing it. Of course, in this case, I'm calculating y bar. So let's finish that, and then I'm gonna show you something else. You have no idea how many times I have heard from the students, even though I explain it in class, even though I explain it in the videos, oh, I cannot do this problem because I don't have that number over there. You do have a number over there. Once again, this is the type of situation that you don't put together previous knowledge and new knowledge. This is the equation of this part. So if you plug this x into here, you're gonna have that y is gonna be equal to 1/4 times x squared, but x is 4 squared. So y equals 4. Then that means that this distance from here to here is 4 also when this is 4. So don't tell me, oh, I couldn't do that problem because I didn't know these values. You have the equation. Sometimes you have two functions, and that's why I'm telling you go to the study sets and check the study sets. And you can calculate those 2 points by intersecting two functions. If you check the study sets, you're gonna know what I'm telling you right now. So then you put everything there and you say y bar is the integral of y multiplied by dA, and dA is this one, 2y to the 1/2 dy divided by the integral of dA, so the integral of 2y to the 1/2 dy. And now the other part that comes is the limits of the integrals. The limits of the integrals, in this case, of course, this is 4 and this is 4, so there's no brainer, it's from 0 to 4. But what if these two numbers are not the same, which is the majority of the cases? Then you look at your differential of area. Your differential of area is this one, like that, right? This is your differential of area. So you are sweeping that differential of area from here to here. You have to form that area just by moving that differential of area. So that means that it has to go from 0 to this 4 here, this 4, in that direction. So from 0 to 4, from 0 to 4. And once you do that, the only thing that you have to do basically is finishing the integration of this. So this is gonna be, I'm confident that you know more integrals than I do. So the integral 0 to 4, this is 2, this is 3 over 2, y divided by the integral of 2y 1/2 dy. And then you do this part here, you add 1 to the top. So this is gonna be basically y to the 5 over 2. And this is 4/5. These two and these two are gonna cancel out because these two are, you can take out of the integral. And those are constant, so this is gonna be 4/5 here. And the bottom part is gonna be 3 over 2, 2/3. 2/3. This is 4/5. 4/5, yes. And this is 4/5, 4/5, 4/5. 2 y to the 1/2. There's something going on here. 5 over 2. Yeah, 4/5. This is 2/5 then, right? Because I'm eliminating. Well, let me put it like that. 4/5 and 4/3. Y to the 3/2. I was canceling these two because I can cancel those two. And this is from 0 to 4 and from 0 to 4. And once you solve these, then you have 4/5 multiplied by 4 to the 5 over 2 minus 0 divided by 4/3 multiplied by 4 to the 3 over 2. This and this cancel out. So this is going to be 3/5. And this is going to be 5 over 2, 3 over 2. This is going to be a square, right? So this is going to be 4 squared. I guess. I don't know. I really don't know. And this is 9.6. No, this is wrong here somehow. Let me see this. It did something weird here. 5 over 2. Oh no, because 2 over 2 is 1. It's not 4 squared. So it's 12 over 5, which is probably also wrong. Yeah, 12 over 5 is correct. 2.4. Yeah. What units? What units? Anybody?
Meters.
Why?
There are no units.
But I didn't keep track of any unit. But of course, if we're measuring distance, has to be in that unit, in the same unit that we are measuring. Is that difficult? I mean, if you are taking calc, I don't know if what calc you see, integrals, calc 2 or calc 3. I'm
Calc
asking.
2.
Calc 2 starts off.
Theoretically, all of you should know how to do that. Now, if I want to do this one, and you want to follow the same procedure that I follow, the same one, I'm telling you, then I look at this letter, and then I'm going to measure this distance x in that direction. Then I have to select my differential of area perpendicular to that one, which will be this one. And the main problem here is just determining that differential of area. So that differential of area is this dy multiplied by this distance. How much is that distance? Anybody?
4 minus our y equation.
Okay, yeah, but that is
Isn't it supposed to be dx?
no. This one, yeah, this is the x, yes. But I'm asking you this distance now. This distance. How much is that distance? Well, believe it or not, this is the most complicated thing when you are solving these type of problems. And this is where people get all messed up. And I don't know why, because this distance, if you look at this y, that y is giving me the height of that curve at any point. But I'm not interested in this one. I'm interested in this one. And I know the total distance is 4 because I already calculated before. So it's going to be 4 minus that distance. That's all the thing. So the differential of area for this part is going to be 4 minus the total distance minus this one, which is defined by that equation, 1/4 x squared multiplied by dx. And that's my differential of area. Once you have the differential of area, it's the same thing. You put that into that equation, x multiplied by that. Divided by the integral of the a, but the integral of the a is the area. And I already know the area because I calculated the area here. The area is not going to change because I'm selecting a different differential. The area is going to be the area. So if I know the value of the area, just put it there. Put the whatever value is this value here. So 4/3 times 4 to the 3/2. That's the area that we calculated from before. I don't have to recalculate that because I already know how much is that. And then the only thing that I have to do is integrate that. Now, once again, if you look at your differential of area now, this is my differential of area. It has to go from this to that. In that direction is that I'm sweeping the shape. So that has to go from this 0 to this 4 here. And I'm making emphasis on this because in this particular example, both of them are 4. But it's important for you to know what is the 4 that I'm referring to in that problem. Now, once you solve this is just going to be equal to the integral of this. It's going to be 4x squared divided by 2, so 2x squared minus, and this is going to be x to the third, and this is going to be 1/4 x to the third here, x to the fourth divided by 16, so minus x to the fourth divided by because this is x to the third, right? X to the third, when I integrate that, it's going to be x to the fourth divided by 16 from 0 to 4. And I guess this is correct. I don't have this here. So I'm hoping that is correct. So this is going to be 32. This is going to be 32, 2, 30, 30 divided by that thing over there, which is 30 divided by 2 times 4x squared divided by 2 is 2x squared. This is 1/4 x to the third on 16. So yeah. So this is gonna be 4/16. This is gonna be 16. And this is gonna be 32. So this is gonna be 16, and this is gonna be 16 divided by this. Uh, $1.5. That will be the location of the x coordinate of the centroid. Now, what is the next step? Let me see if you watch the video. Is there any next step? I see people chatting over there, so let me see. What is the next step? No, no.
Plot the point.
Checking my homies. What is that? Checking my homies. I don't know. Visually confirmed. Plot and visually confirmed. Yes. Checking my homies. Now I know what you're saying. Now this is a step that is not going to take you time, and it's not gonna definitely it's not gonna tell you if you are correct, but definitely it's going to tell you if you are incorrect. Because once you plot these values in the drawing that you have, you're gonna realize that this value is 2.4 in the y direction, meaning this is 2, right? 2.4 is a little bit over, and 1.5, this is 4, is somewhere over here, kind of. And then you have to see if that point makes sense from the point of view of center of gravity or centroid in this particular case. You can see that that point, the areas above, below, side, and side are kind of balanced. So in other words, if you put your finger somewhere over there and try to hold it in this direction, you're gonna be able to hold that. That means that that location is probable. But if you get a value here, for example, in the x, and that value is bigger than 2 in this case, will be that is to the right of the center. It will be somewhere here. That value wouldn't make any sense. And that will be an indication of, hey, go back and review what you did. This is a step, this is the first method, let's say, of solving that. Any question? Any question?
I have one question.
Yeah.
For the A, for the X, you plug 4 over 3 multiplied 4, 3 over 2. Can we plug the DA like you wrote in the top 2y, 1
Yeah,
over
but
3?
I said this is the first method, okay?
Oh, okay.
This is the first method. Now, let me explain you a second variation for this method. This is the method that you follow like a recipe. That's it. First do this, mark the distance, put your perpendicular differential of area, find how much is that perpendicular differential of area, find the limits in the same direction of y, integrate. The same thing here. Measure x, differential of area perpendicular. The limits are going to be measured in this way, in the x direction. Find that value, which is the most difficult thing to do, and do the integral. That's the way. Now, the second approach will be this one. I'm going to keep it the way that I did it. But the second approach is something like, let's see, I have another.
I do have a question first before we move on
Yes.
about the first part.
Yes.
So when you're solving for dA, where you find like x is equal to 2y to the 1/2 power.
Well, we're solving for what dA? This one?
So for the first half,
Uh-huh.
the first half, where you have the equation y is equal to 1/4 x squared.
Uh-huh.
You're using that to solve for x. You're solving for x in that equation.
No, I'm not solving for any x. I don't understand your question.
My question is, how do you get at the top right corner where you have x is equal to 2y to the 1/2 power?
Ah, here. But I was pointing at this one. You're talking about this one.
Yes.
Yeah, of course, because you need this distance, right?
Mm-hmm.
That distance is provided by this equation, so you need to know how much is x.
So you're solving for x in that equation. So how?
Yes, because that's what every coordinate in this point is xy, right?
Mm-hmm.
And those xy are defined by this equation here. So if I need y, y is given there. But if I need x, I have to solve it from here.
So my question is, how do you get 2 then? Because I got
How did I get
confused.
2? Because when you solve for this is 4y equals x squared. And when I take a square root of both sides, this is 2.
Okay. I knew I missed. Okay, sorry. I knew it was something simple that I missed. Okay, I understand now. Thank you very much.
Okay, good. No, I mean, don't be sorry, because you should feel sorry if you don't ask the question and then comes the exam and you have it wrong because you didn't ask the question. Then you should feel, well, not sorry, you should feel really mad. Now,
Okay,
the
sorry.
other method is this.
Okay, then I'm not sorry.
Now, I work out the first problem, and in the first problem, I say this. I say, I am going to measure y, and this is going to be my differential of area, this one. I have that differential of area. And that differential of area is defined by 2y to the 1/2, and I say this one here is dy. That's the differential of area that we define here. Now, what if I want to use the same differential of area for calculating x bar? So I can say x bar is the integral of x dA divided by the area. I'm not going to go over this again because we already know how much is the area. I'm just going to go over this part here. But then I have to measure the distance. You know, when I measure here x, I measure x, right? When I measure here y, I measure y. That distance, if you remember the videos, and if you remember the definition, when I started doing that definition, I did something like that. And then I put some axes here. And then I say from this to here, and from this to here, and from this to here. And we measure those distances, right? Now, when I say from this to here, that here is what? What is this point? You were supposed to what? By the way, guys, don't get confident because we're finishing that we cannot have class activities. If I see that you are not reading what you have to read before class, that's in detriment of your education. I will do a class activity to force you to read it again because I really need you to read those and watch those ahead of time. What is this point? What those points represent?
The centroid.
The centroid. That's exactly the answer. This is the centroid of each one of those figures. So now, if I decide to use this differential of area, but I'm going to measure the distance x, that distance x has to go to the centroid of that band. And the centroid of that band is there at the center. In the other case that we just did, it happens that this is the centroid right there. I'm measuring to the centroid because this is a differential. So I'm just have to go from here to that band, any point, because this is the center. But in this case, if I'm going to do that, I have to go from here to that point, which is the centroid. Now, this distance x is what the book and Chegg and all the other spices call x wiggly or x tilde or x something like that. And that is the distance from the axis to the centroid of that shape. Now, the centroid of that shape is going to be half of this distance. That's what it's going to be, half of that distance. And how much is half of that distance? Half of that distance, I know the distance from here to here, x is a square root of, or x is 2y to the 1/2. That is that distance. So half of that distance will be half of that. My x tilde will be half of that from here to here. That's that thing over there. And that's the second approach. So if you use that second approach for doing that, then you're going to use the same differential of area, which is that one, but I'm going to multiply that by this distance. And that distance, I don't have that. Yes, I do have that, I think. It's going to be equal to that, which is y to the 1/2, because 2 times this and this cancel out. multiplied by that divided by the area, the integral of that, and the integral of that between 0 and 4 in the y. Remember what I'm measuring here now. You have to follow the differential of this. So once you do this, you have what? 2y squared divided by 2. This times this times this is y. Y 1/2 times 1/2 is y. So 2y squared divided by 2 divided by the area from 0 to 4. So this is 16 divided by the area. I don't know, I'm doing this live, so I don't know if these are correct or not. 1.5, which is the value that we got before. And that's the second method. Just going directly, using the same differential of area and going to the centroid. That method, I would recommend to use it in a specific, first you have to have a really good understanding of what is happening there. But I would recommend to use that in specific cases, very specific cases, unless you really know what you're doing. And those specific cases, one of them is in your homework. And I don't remember exactly if it's in your homework for centroid or for moment of inertia, but if you have a figure that is something like this, like that, and you have an equation defining that, and then you have to calculate the y bar, like that. If you follow the first method, then you have to measure y in this direction. And you have to put your differential of area in this direction. But look what happens if you do that. If you do this distance is, let's say this is, I don't know, b. So if you do that, this distance is gonna be b, right? But if you're here, and you measure y at that point, for example, then that distance, it doesn't make sense because that distance should be only this and that. So it's gonna be wrong, whatever you do. So for that particular homework problem, I'm telling you, if you have this situation, you're gonna have to do the differential of area in this way, and you're going to measure the distance with that y wiggly over there in that direction, or with the x in that direction. If you don't know what I'm saying, as soon as you do the homework, you're gonna realize what is happening there, okay? But just keep that in mind when you do the homework. And once again, I don't remember if this is a homework for centered or moment of inertia, but in both cases, it's gonna apply that part. Second method. Now let's go to the third method, which personally, I never use. But some of you, any question here? Some of you, I know you're gonna like that method. And I don't like it because I'm not gonna say that I hate math. Actually, when I was a kid, I thought I was gonna be a mathematician until I start realizing that math is just a tool. But the other method is, I don't have more papers. No, I'm gonna use this. What is the equation there? Y equals there you go. And the other method is is something that you probably are doing now, or you did it very recently. Instead of me measuring that distance X or that distance Y or that distance whatever, and finding a band, I'm going to say that my differential of area is this one. That's it. That's my differential of area. And this is something that you learn. You learn how to do that. And you learn how to do that in math, in calc. Because let's say that I want to calculate the area first. You remember, the equation is the same equation, x dA divided by the integral of the A. That's the same equation. So if I want to, let's say, find the area first of this, I can use double integral for that. And I just can say this is going to be the integral, the double integral of, and then you decide how you're going to do that. And I'm going to put here dy dx. And if I'm going to put here dy dx, I know that this is going to go from here to here. And this is 1/4 x squared. And this is y equals 4. And in the x direction, it's going to go from x equals 0 to x equals 4. And then I'm going to have that. And then I do that integration over there in double integral. First, I do this, and I'm going to integrate this part. So if I integrate this part, this is going to be a constant. So this is going to be just y, the distance, or yeah, y dx. So then this is going to be equal to the integral from 0 to 4 that y. And when I evaluate y, it's going to be this minus that. So there's going to be 4 minus 1/4 of x squared dx, like that. And then when I solve for that, this is going to be equal to the, this is going to be 4x minus x to the third divided by 12, x to the third divided by 12 between 0 and 4. And this is going to be 16. So 4 times 4 minus 4 to the third divided by 3. And this is going to be 10.6. That's going to be meters squared. So if you go to the previous problem that we just did, that was the area that we got. Let me see how much is that area just to check it. I'm doing it correctly.
That's true. I calculated. It's 10.6.
See that?
It's 10.6. It's correct.
10.6. So it's correct. So the area is correct. The calculation of the area that we did using double integrals is correct. So the only thing that we have to do now is decide what we are doing. We're gonna do our x bar. Okay, let's do our x bar. So if I'm gonna do x bar is gonna be, once again, 0 to 4, 1/4 x squared to 4 of x. Now the equation is gonna be the double integral of x dA. So it's gonna be x times dA, and dA is the y dx, same thing that we did before, divided by the area. And I'm doing this fast because I don't like it. And I don't want you to learn it unless you really know it. So if you really know it, go for it. I don't mind. I don't mind. But if you don't have to learn this. So then you do that, and then it's going to be the same thing, 0 to 4 of this, but this is equal to what? This is going to be equal to 4x. When you integrate that, it's going to be 2x squared minus 1/16, because this is going to be there, 1/16 x to the 4 from 0 to 4. This is already the result. Divided by the 10.6. And when you do that, then you should get x bar equals 1.5. I know that some of you are going to jump at this and are going to say, yes, that's what I wanted. That's the method. And some of you are drooling even, because some of you are really liking math. But this is the method that I dislike the most. But I don't have anything against you. If you know how to use it, use it. My recommendation, once again, is either use the first method or the second method, unless you're really good at this. If you want to use the first method is a no-brainer. Measure distance, perpendicular differential of area. Measure distance, perpendicular differential of area. Unless you have a situation like this. If you have this situation, then you have to use the second method. But you're gonna learn more about this as you practice. So this is the first part for today. Centroid using integrals. Questions? Questions?
Does the third method work for everything?
Say that again?
Does the
You have a question?
about the backward method?
I'm gonna tell you something that I don't want you to use. Because if I tell you to do it by integrals, you're gonna do it by integrals. If this is a parabola, you know how much is the area of that, right? You should know how much is the area of that. 2/3 of b times h. That's the area of that. So how much is 2/3 of b times h? 2/3 of b times h is 2/3 times 16. 16 times 2 is 32. 32 divided by 3, 10.6. And you knew that formula from before. So theoretically, if I'm not asking any method, you could calculate the area like that without any problem. But practice, please practice, because sometimes you're gonna see this equation and you're gonna think it's a parabola and it's not a parabola, it's a different function, and then you're gonna try to apply that and that's gonna be wrong. But yes, you can use that as 2/3 of b times h also. Let me stop this here. Not the class, don't be excited. I'm gonna stop this video because these videos are getting too long. Stop recording. Oh, somebody's just coming to the class.